In this video, we're going to go over some stoichiometric calculations. These calculations are going to involve concentration, moles and volume. So if you do some examples. In a titration, 25 decimeters cubed of 0.1 molarity sodium hydroxide is used to neutralize 17 decimeters cubed of hydrochloric acid. Put the reactants are in aqueous solution, calculate the concentration of hydrochloric acid. So if you start by writing the equation, we have sodium hydroxide plus hydrochloric acid, and that will give you sodium chloride plus water, right? Because we've got acid plus alkali gives salt plus water. And you know the charges balance because sodium is an ion, so +1, and hydroxide is -1, so together they're neutral. And then hydrogen is +1 and chlorine is minus, so it's ionic bonding will be in those two. So if we draw our table, we have sodium hydroxide, hydrochloric acid, we have concentration, moles, volume, and ratio. So we've got 25 decimeters cubed of sodium hydroxide, so 25, 0.1 molarity. Molarity is just moles per decimeter cubed. It's just another way of writing it. Concentration is 0.1. 17 decimeters cubed of hydrochloric acid. So what we need to do is work out the moles, but when we fill in this ratio part, we look at the equation and the stoichiometric coefficients. So the ratio between sodium hydroxide and hydrochloric acid is 1:1. So if we work out the number of moles, concentration equals moles over volume. So moles equals concentration multiplied by volume. So the number of moles of sodium hydroxide is 0.1 times 25, which gives us 2.5 moles. Because it's a 1:1 ratio, we need 2.5 moles of hydrochloric acid. To calculate the concentration of hydrochloric acid, it is moles over volume. So moles over volume, the concentration is 0.147. So 0.147 molarity or moles per decimeter cubed of hydrochloric acid. If we do another example, in a titration, 12 centimeters cubed of 2.4 molarity magnesium hydroxide solution, it shows here, is used to neutralize 30 centimeters cubed of hydrochloric acid solution. Calculate the concentration of hydrochloric acid in grams per decimeters cubed. So first here we need to consider units. We have centimeters cubed here and decimeters cubed here. We also have grams. So in a previous video when we did stoichiometric calculations, we used moles equals mass over mR. So we'll be using that to get from moles to mass, because our equation is moles per decimeter cubed, but it wants grams per decimeter cubed, so we'll be using that later. So if we write out our equation, we have magnesium hydroxide solution, so MgOH2 plus hydrochloric acid, and from that, so that will give magnesium chloride plus water. So if we balance out our reactants and products, we make sure the charge is equal because magnesium has an ion charge of 2+, so hydroxyl 1- multiplied by 2, those will cancel. Hydrogen 1+, Cl 1-, so those will be neutralized. Magnesium is 2+, Cl is 1-, so multiplied by 2, that will cancel, and of course water is covalent. So if we look at balancing the stoichiometric coefficients, we have 1 magnesium, 2 chlorine, 2 chlorine. If we look at the hydrogens and oxygens, we have 2 hydrogens times 2, so 4 hydrogens and 2 oxygens. So we need to multiply this by 2. Now we've balanced our equation. So if we do our table again, we have magnesium hydroxide and hydrochloric acid. So you have concentration, moles, volume, and ratio. So we're given 12 centimeters cubed, so the conversion from centimeters cubed to decimeters cubed is divided by 1000. Then from decimeters cubed to meters cubed is divided by another 1000. And to go the other way would be to multiply. So if we fill out our table, 12 centimeters cubed of magnesium hydroxide, so 12 divided by 1000, put it in the volume, and the same for hydrochloric acid. So we also put in the concentration and our ratios that we've just worked out from balancing the stoichiometric equation. So it's 1 to 2. So now we can use the equation concentration equals moles over volume to work out the moles and therefore the concentration. So the moles is concentration times volume. So we have 0.0288 moles of magnesium hydroxide. Because the ratio is 1 to 2, we multiply it by 2 to get the moles of hydrochloric acid. 0.0576. Then to calculate the concentration, it's moles divided by volume. So 0.0576 divided by 0.03, concentration of 1.92. So as mentioned before, concentration, i.e. molarity, is moles per decimeter cubed. So if we write it out, we needed 1.92 moles per decimeter cubed of HCl. However, it wants it in grams per decimeter. To convert moles to grams, we needed mR. So mR is the atomic mass of the element. So we have hydrogen and chlorine. Hydrogen is 1, chlorine is 35.5. So to convert, we would have 1.92 moles per decimeter cubed. To get from moles to mass, you multiply by the mR. So we multiply this by 36.5 because that is the atomic mass of chlorine plus the atomic mass of hydrogen. So the concentration of hydrochloric acid is 1.92 multiplied by 36.5, 70.08 grams per decimeter cubed. And that's it.